All right, so hello everyone. This is Sandeep Giri from No Big Data, and we'll be discussing in detail the map reduced today in Java and how can we customize it further. All right. Hey Amit. So can everybody hear me clearly? Great. All right. Recording is on, so now we can start. All right. So yeah, here we go. So this in this discussion to this problem, you could actually send the email directly to me. Okay, because that online subjective question has not been prepared for this one. So we were discussing about the second problem based on the content from a very large text archive. Formulate the next word recommendation, and for each word, prepare top 5 recommendations of the word that will go next. Okay. Now, so yeah. So a quick answer will be sufficient. So can somebody give us an answer? Anyone? So basically question is that given a huge text, you have to form a word, and after typing that word, what should be the recommendations? For example, after happy, you have to have the when somebody types happy, the next recommendation you need to give is birthday, new year, marriage, based on the frequency of the words that come after happy. And this frequency is calculated from large corpus of text. Okay. Count the frequency of the word pairs, good, and sort to get top 5 frequent occurrences. Good, good. Split the text into unique words, then scan the entire text for okay. So what you're suggesting is that first create a big list of unique words. Then after that, for each word out of these unique words, we prepare word and the next word kind of a list, right? And then we do this. So if you have to do it if you have to do it in a traditional manner, then you will be scanning the whole text n times if n is the total unique words, right? So could we avoid scanning it 10 times, because that is going to be very costly for us. All right. But that's a good attempt. Split the word to form the first word as a key and the second word as the value. Then club the values to form the suggestions. Good. You okay, that's good, Sushant. Okay. You would have to find occurrence of happy and the word following group and count. Okay. So and as you know, Julie, that every group and count can be actually modeled straight away into MapReduce. Okay. So probably you are very closer. Okay. Abhinav's answer is that key, word delimiter, and subsequent word. Okay. All right. All right. So that is good, Abhinav. That is good. And the frequency. Okay. Abhinav's answer is good. Abhinav is saying the create the key as word delimiter and then subsequent word. And the value is frequency. Count frequency. Count frequency of word pair as the aggregation of the value for same key value and get key. Interesting. Seema's question: if we find the word pair, there are so many possibilities, and for a 10-word sentence, there can be 9 possibilities. Yes, it would be 9 possibilities. So it's not the standard word pair. We are not doing a permutation. Um, okay, okay. Let me try to understand. One question is, if we find word pair, there are so many possibilities. For a 10-word sentence, there are 9 possibilities. Yes, but why would that be a memory problem? If you form your map reduce properly, then that should not be a memory problem. Right. So Mega's answer is also correct. So count the frequency of the word pair as in first word and second word, right? And get the aggregation of the same key. Okay. All right. All right. So you all are almost there. Almost there. Very close. So this would be my first attempt. Okay. Say you have this huge text. How are you is, and then second line is Ram, happy birthday to you. Let me make it capital R. To you, happy new something, and it goes on. Good, good. So first problem, okay, okay. So there is Julie's answer to this. And anybody else see any problem with this? this approach? Yeah. So you got the first problem correct, Julie. What would be the next problems? So here key is how and value is r. Key is r and value is u, and so on. So if we could do the reverse, as in r is the key and how is the value, then basically we will be computing that what should be typed before r. We will be able to figure out by analysis that what should have been typed before r, right? If we do the group by that key. I'm answering to Julie. Why wouldn't R go as key and how goes as value? U goes a key, R goes as a value. In those cases, it could be it would be very difficult to figure out. Basically, there you will be able to easily figure out what should have been typed before a word. Abhinav's point is, will it make sense to filter stop words? Good, good. Yes, it will make a lot of sense to use stop words. Stop words are the words which you want to skip, the common words generally, or some other words which you want to skip. Now, Sushant's point is the probabilities increase exponentially. No, we'll not be double counting if you see. But we are actually skipping things, as you see here. All right. So first problem with this approach is, first problem is that here for each word, say R, there'll be too many words who might come. Here, if you see, if they, or is to, there are so many words which will come after R is and those words, right? So, and because of that, these may be like 1 million words in the reducer. Now, to process those 1 million words in the reducer, it is going to be huge problem. Right. So that is one problem. Second is last word should have paired with the first word here. Birthday should have paired with two. You should have paired with Ram. But we couldn't do it because our standard way of Hadoop did not give us the whole paragraph. Instead, it gave us a line. It did not give us a sentence. It gave us a line, right? So that is one problem which we'll face in this approach. So there are two problems. Basically, one is combining the last one with first word, and second, avoiding these kind of pairs. These pairs like Ram and Happy can be avoided still, but we will not be able to combine using standard way the last word and the first word. Yes, so we'll have to split on the sentence ending punctuations and then take care. right? So we'll have to figure that out, as Seema is saying that we could actually end at period or exclamation or comma etc. So it all depends how would you form it, right? So basically, those standard way of natural language processing you will have to take keep in mind to take care of this. So this can be taken care of, but the problem is this last word has to be joined with this one, and that is not something Hadoop provides you by default. Okay, so we are going to discuss that problem today. You got the problem, right? The last word should be combined with the first word here because the sentence has not ended here. Okay, although you could always argue that if our corpus of text is huge, these kind of mistakes can be overlooked. The normal sentences will outrun these kind of anomalies in case your text is really huge. Okay, but still you should not be relying on big data to rectify your mistake in the manipulation of the data, right? But generally these kind of mistake could be overlooked because in a sentence there are nine pairs which are correct, one only one pair is wrong, and if you go again and again it's a big data, then the out when you do a frequency computation, those anomalies will be eliminated. Okay, so let's discuss how could we bring you and Ram here and birthday and two to make a pair, and also a better approach here as compared to the approach we did would be to create the key as a composition of first word and second word and the value as 1, and then count the frequencies, filter all the things which have a certain uh, we remove all the key values which have frequencies below a certain number, and then you prepare the you prepare a second pass using this mechanism. Okay, so that is something you can think about. Okay, let me read out Mega's point. So we have to combine the last word of the first line and the first word of the next line, even though the next line is the new line. Not really, not really. So if you had a period over here, we don't have to go to the next line. But if you see, this is the whole this the sentence has not ended. So instead of we operating on this text line by line, we should be operating on this text sentence by sentence, right? That's the difference. We should be operating on this text sentence by sentence. But the standard input that is provided by MapReduce to you is line by line. So at a time, your map function will be getting only one line at a time. Okay. So when you will have a discussion, so in your map function, you will get two things as input. Okay, the input first will be the byte count. Byte count. Byte count is the number of bytes on which the line starts, and then line. These are the two things you will provide in the map. This will be your key which will be provided to you, and this will be the value. All right. Now you will have to prepare the output out of this. So somebody was suggesting me that by using this byte count, we could actually group the last word with the first word. Okay, and that was a very interesting take. He said that prepare one is prepare key value, normal key values, normal key values based on first word and last word. And second, he said that prepare the byte count of proposed byte count for the last word. Okay, and then so if you prepare a key for first word as the byte count, okay, byte count, and line 0, let's imagine this. Okay, let me just say words 0. Okay, and this is first key it is going to emit, and then it will emit the rest of the keys, such as key for I equals 0 and I less than words dot length I plus plus. So we are basically iterating over all the words, and words here, he let's put it -1, and then okay, then at the end of it, emit byte count plus byte count plus word words sorry, line dot length. Okay, and then word words I, and that's all. This way, if you notice this one and this one, basically based on the byte count, on what byte a particular word is starting, we'll be able to bring together the first word and the last word. But this is too hacky a way. So somebody suggested it. I'm not recommending it as a solution, but this is one of the ways you could utilize the byte count information to manipulate to do a lot of things. Okay, so let's get into, you will understand it better when you look at the example, look at the code, and then you'll be able to appreciate this approach. Okay, so this approach is basically bringing the word, this word, last word, basically this is the last word of the line, and we are printing it with the byte count of the next word of the next line, first word of the next line. This is the byte count of the first word of the next line. And first word of the next line will again be emitted just like this. Okay. And all of these words should be emitted only if the sentence is not ending at some point. All right. Now, here we go. Can we just store the last word in the memory? Yeah, you can. You can just store the last word and flush it. No, the problem is, let me think about it. No, the problem with that approach is you should always imagine it this way, that maybe the first line is on one task tracker, second line might be on another computer altogether. All right? It's not a simple iteration going on. The only way to bring together these guys is using a sensible key which forces them to come together. So that's the idea. And byte count is one such thing. So for first word, we print the byte count as is. For the last word, we print the byte count of the next word after the last word, which is going to be. So we are trying to bring the first word of the next line with the last word of the current line. Okay. So this is one approach. I don't recommend it. I'm just trying to put forward a solution suggested by somebody from my class, and this did make some sense. Okay, it also tells you that there is something called byte count which you get from MapReduce. All right, so these all questions we have already discussed. Okay, now, so today we are going to discuss exactly this part, not this part, this question actually. So basically, we are going to discuss this question today. So the whole of the HDFS block is not available on a node. Okay, there has to be some sort of movement, right? And second thing is sometimes the line wise processing is not suitable for us. As we saw in the last example, the line wise processing was not suitable for us, right? That is a completely not acceptable. Instead, we want our own custom way of processing text. We don't want line wise. What we want is sentence wise processing. Can we do that? Can we customize MapReduce to a level that we start processing things in terms of lines and paragraphs, sorry, sentences and paragraphs rather than lines and a bunch of text? Okay. So, and the other thing is, you must have been wondering, although we had split it up our text into into exact byte size, right? The HDFS ruthlessly cut the blocks, and when we are running the MapReduce, we are getting the full line, right? We are guaranteed to get the full line. How is it happening? So those kind of things we are going to discuss today. All right. Now, so let's, before getting into that, let's just try to do a simple map reduce in Java, and then we get deep down into how do we customize, how do we control our map reducer. All right. Now, let's start with why in Java. First, primary support, and basically Hadoop was written in Java so that Hadoop could be run on any kind of machines. Now, once they had written it, the best way to customize Hadoop would be Java because that's what it is written in. And you can modify the behavior to a very large extent. Though you can write most of the stuff using things like streaming job, but still there are few things you could do it better in the Java itself. Okay. Say if you had to write something like a pig client or a hive client, they are better written in Java rather than any third party language. Okay. So these are few steps. First, install Eclipse, then create a Java project. Okay. So son, don't worry. If we will be, it will not be too difficult actually. Okay. And basically any simple Java tutorial should be sufficient for you. Okay. And any simple Java tutorial should be sufficient for you. Okay, so all right, so we have this. Yeah, I would like to discuss it offline. All right, so here we have one. So all I did was I created a project, new Java project. Okay. Say we call it 24 Jan 24. Okay. Out of this, we first of all we changed the JDK to from 7 to 6. Why are we doing this? Okay, why are we doing this? So that if on the server, if the Java virtual machine is of version number 6, it should be able to run our code. If JVM is 6, it cannot run anything above 6. If you compile your code in 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 Java 7, it will not be able to run that. Okay? So, and but if your JVM is in 6 and the Java code you wrote is compiled in 5, the JVM 6 knows about it and can run a older code. Okay? So that is why when you're coding, you need to be fairly conservative about to what platforms you want to be able to run something. Say if you are building an Android app or you're building any app, you will try to target a platform on which it can run the lowest possible platform rather than the latest platform, right? So as an engineer, as a developer, our tendency is to always be conservative when we are targeting some platforms. Okay, if we are building a web app, we always try to be conservative in terms of we should be able to run at i7, Chrome, and everything. So similarly, yeah. But if you have JVM 7 on the server, then this is not needed. But still, being tomorrow your organization decides that we want to move to Amazon. Okay, now you should not need to recompile your code because Amazon also has MapReduce, and there are high chances that the latest one is not available there. But as of today, most of the JVMs are on 7. Okay, so this step number 4 is not really required. All right. So, all right. And then basically create a Java project, add all the libraries. These libraries are available in the project that is being shared on the My Courses page. And from there, you will be able to create the project like this. Okay. So here I created my own package and then started building my mapper reducer. Okay. And how do I change all of this? So here, right click properties, and there I have Java build path. You can add whatever library you want to add. Generally, whatever has been shared in the project, you put all all that, browse to all of those libraries and select there. Okay. This project I have shared on the course page. So here we have this. All right. And the compatibility part, let me show you. Go to properties and libraries. Here you see Java 6. Okay. If you want Java 7, you can click on add it and then select this. Okay. Now, so we are all set. Now is the time you start writing a class, create a fresh class called stub mapper that should extend. Is the font visible to you? Font okay? All right. So here you see stub mapper. It basically extends this particular class, okay, this particular abstract class, and it tells that this is what my key input key type for the mapper is object, input key type is Input value type is text. You remember this is going to be byte count, this is going to be our line, input line, and this is our output which we are promising step mapper. This is my class name. It is promising that hey, my data type for output is this. Okay. So basically, those who are not from Java background but who has been working on C++, this is sort of generics. The way we have generics in C++, we basically are defining that we are extending a class called mapper and with these kind of data type. Okay. Say we want to create our own list. If we are extending a list and we only want to keep a certain data into that, then we'll say my class extends that list and define the data type what we want to put in there. Okay. So it's like extending something with a rigid data type. So this is what it is, so that we don't make a mistake or we don't have to cast it. Okay. This is something which is specific to strongly typed languages. It's not true, it's not valid for languages like Python. Okay. So we are basically extending our mapper with these kind of data types. These four data types are two for input key values, two for output key values. Okay. Similarly, now once you have done that, so eh, the this is sort of common for all. Okay. You'll have to create a function called map, and based on what do you want to output from, what kind of data type you want to output from your mapper, you will be defining these two, and exactly same thing you will be able to put in the output of a mapper would go into this variable called context. Okay. So instead of printing onto a standard output the key and the value, you will be putting it into context. Okay. Now, so here we have a mapper which has given us a key and a value. The value is our line and key is the byte count from which the line starts. Okay. The byte count for the first line would be 0. Second line it will be equal to the byte count length of the first line and so on. Okay. This is not the line number, it's the byte count of the character. Right. And why is it byte count? That is something you can think about. Why? Because HDFS gives you the only information it gives you is the bytes, and it is easier to count the bytes than count the lines. All right. Great. Now we have a list of words. So this is our input line. We are splitting it by spaces or tabs. Then we are iterating over the words, and then we are replacing all the special characters. So actually you can, for time being, you can remove this. Okay. So for each of the words in the input, what we are trying to do is we are spitting out the word and a numeric one. Okay. Now what is this text and long writable? That is something we need to discuss. So instead of saying ideally the in the ideal world it should have looked like this. Okay. Not like this. Okay. Now look at this. So what we are saying to context is, hey, we want to give key this and value 1. Okay. It is up to you. If you don't put anything in the context, the program is not going to complain, but there is nothing is going to get out from your code. Okay. There will be 0 keys and 0 values, given to the reducer at the end of the day. Now, so why this kind of a syntax? Why we are creating a new class the standard instead of using a standard string? We are creating new text on top of a word and passing that new object as the key, and then creating a new long writable and passing it to the context. Now, why did Hadoop basically realize that the way serialization happen in Java is not good enough for them? Okay, because these keys need to be serialized, put onto the disk, and then there are a lot to be done on top of these key and values. Therefore, they realized that it would be better if we coin our own data types for serialization and deserialization. Okay, and for serialization deserialization, the engine Hadoop uses is called Avro. Okay, so this is basically done for uh, using Avro. It's a I mean, the process of serialization means converting anything into which is in the memory, putting it onto the disk with the proper way, so that there is no problem while we try to read it again. There should be no confusion at all. Okay, so this is how our mapper is going to give out key and the value. Okay, by writing into the context. You can only write into the context the data type which you have defined here. Okay, if you try to write here new text, it is going to give us an error. But if you have defined here as text, then it is not going to give us an error, right? You can see that. So basically, whatever data type you are extending with, those are the values, those are the data type you can use with context. Similarly, those are the data types provided to you in the input. All right. Now, basically, this is standard stub mapper. So you retain stub mapper. All stub mapper did was splitted the line into words with spaces or tabs as separator, and then put word 1, word 2, word 3 with numeric 1 as value, all of the words as the key, and 1 as the value for all, right? Now, okay, so we are basically solving this standard MapReduce problem. Okay. Now the next step, once you are done with this, the next step is to create a reducer. Now, reducer has got similar, you extend a class called reducer with these data types. Okay. So this data type and this data type, these two have to be same as what your mapper gave out. Okay. Remember we gave out text and long writable. This has to be the same as what mapper gave out, and this is what you want to give out from your reducer, the key value pair. Key has to be text and value has to be long. All right. Now, when and we have to write a function called reduce, and then we do this. Okay. So on every node in the cluster, what is going to happen is every node will create a new instance of stub reducer once, and e- on each line this method is going to get called. Okay, so for each input is split, for on each computer, on the each machine on which the your MapReduce is going to run, it will create one single instance of this class called stub reducer. Okay, when on all the machine on which your reducers are running, this class is instance is going to be created only once, and the for each input key value, this is reduce method is going to be called. Same is true with mapper. So on each of the node on which the mapper is going to run, one single instance of stub mapper is going to get created, and then for each input line, this method is this method is going to get called. The map method of your mapper is going to get called, right? Now, so in the step reducer, the things you should note is the input which is given to you is in the form of key and the values, right? In the form of key and the values. So whatever you gave it in a mapper, this is what you get here. This is a key and the list of values. This is iterable is essentially a sort of a cursor. If you are from database background, cursor to the list of values, you can iterate over the values. So for one key, all the values available in the system, you are going to be made available all the values in the for that key in the all the values in the input data. Okay, it should not be that for one reduce function gets one key twice. No. Reduce function is going to be called only once for a key. And all the values that belong to that key are going to be there in this. You'll get the basically you'll get the pointer to the list of values. And then your job is to iterate over the values to get to a meaningful result. And once you get the meaningful result, again, you are going to write the meaningful result into the context, right? So here, all we did was we iterated over the values and summed up all the values. We summed up all the values and then we wrote it to the context. Okay? We wrote it to the context. Sounds good? Yes, yes. Abhinav, you got it exactly right. So if MapReduce is written in Java, we get iterable in reducers. While in streaming jobs, reducer gets sorted list of key values. Okay. So reducer is strange in case of not only sorted key values, it will get sorted key and values. Okay, your program reducer will get multiple keys and multiple values, but good part would be that good part would be that the key will be sorted, the input will be sorted by the key, right? So is everybody with me, or have I lost the people who are not from Java? Okay, so let me try to do unjava kind of thing. Okay, so basically if I had to do it in you know a pseudo language like C or JavaScript, so we'll create a class, or you can think of we are creating a file called map. Okay, this is our map file. Under the map file, we are saying we have to create a function called with the name called map. Map will be given byte count as the input and the line as the each line. Okay, and then you will be given something called context. Context is something like system, like console. Okay, the way we say console dot put this, or any basically this is your gateway to give out your data to Hadoop. Okay, and under the map you will basically, in context you will put, you will context in the context you will put some key and some value. Okay, this is what the definition of your map is. Okay, now another file called reducer. Okay, there's another file called reducer. In that you need to write another function called reduce, where you will be given a key and list of list of values. Where, okay, so values is sort of an array. Okay, values equals this. Okay, value 1, value 2, value 2, and so on. Make sense? And then under reduce you are going to write something of this sort. And sorry, reducer will have yes context only again, and we'll just write context dot write, or whatever, put right here. Let's just put it correct way and say key and array dot sum of all the values. It's as simple as that, right? That's what we did in so much of Java code which you see here there. Okay, so here we are basically doing for each line dot split, line dot, okay, split by space for each word in, after splitting the line, this is what you did. Okay, so this is clear to you, right? If I have to write a pseudocode non-Java one without too much of hassle, I would actually write it this way. Okay, and this is what I'm trying to do there. Just that, to make the data types rigid, it has provided us some more bells and whistles here and there. Okay, make sense to you? So this is the pseudocode. It's exactly this pseudocode which is being put here. Okay. Now there are a few more things I would like to explain right here. First is, you can actually do these kind of things. Lots of people come and ask, what happens to the stuff which I write in system.out? All of us are serially habitual of putting our debug statement in the form of system.out.print, system.error.print, or basically trying to print the statement to figure out what's going on inside my mapper, right? Because when you will start working with these mappers and reducers, the first thing you'll be very very cautious, like, because first you have to create all of this code, then there are multiple steps to reach to a point where you'll be running it, and you want to basically debug stepwise, and stepwise debugging is something not possible right away. So writing these kind of statement like system.print, system.out.print, or println, or printf kind of statement which you come from C. So where do they go? We will also discuss that part. All right. Now let's go into SG test and say, right click and say, so once you are done with it, okay, there are multiple more steps actually. So we are done with writing reducer. So reducer is clear to all of us. The next step is binding all of these things together and create a launcher. Okay, we call it driver, the one who is the entry point. This guy is our entry point in the program. Okay, so this is the entry point. You should take a note of this guy. We call it step driver. You can create any class of this name. Okay, when we will be running our program, we will be telling Hadoop that, hey, this is the entry point we have. This is our entry point. Please start the process from here. And what does this guy do? It first checks whatever arguments you have provided, are they correct or not. Then in this we, and also note that these names, step mapper, step reducer, step driver, are just my name. You can keep any name you wish to. Okay, just that while binding all of them together, okay, you have to mention the same name over here. Okay, you have to mention the same name over here. And so when we are telling Hadoop, we are giving the address of this guy, giving the name, okay, execute step driver for us. Step driver knows. Step driver first has created a config, okay, and then told this job which is creating that, hey, your mapper class is stubmapper.class. Okay, you might create some other name. Whatever name you create, you mention it here. And to the job, it is also mentioning this is my reducer class. Okay, this is absolutely optional. Okay, if you don't specify, it's completely okay. But we'll discuss why we are specifying key LU data types. Okay, here we can also specify what kind of output are we expecting out of our mapper and out of our reducer. Okay, next is you can specify things like partitioner. Okay, and you can specify how many reduce tasks you are going to use. Okay, partitioner is the class who will basically split the keys into multiple reducers. But let's keep that aside. Let's keep that on the back seat for now. Okay, and here we have uh, okay, and also these are just optional things. Okay, now one more thing you need to note is here you also define something called input format. This is optional. If you don't define the input format class, the stuff you are going to get in your mapper is line wise input. There are multiple kinds of input formatter. We'll talk about those, but for time being, so these are commented line. Those who are still confused, these are commented lines starting with double slashes. Although I'm a little late in telling you that. Okay. All right. And the next step is we are adding the input path. Input paths using a function called file input format dot input path to this job. Okay, and from the argument of the program. Okay, if you note that the argument of the program is input directory and output directory, correct? So this is our entry point to the program. Now once you are done with this, all you got to do is export this into a jar, and let's say we give it a name, we give it some name, we call it word count, and sg-test is what we are trying to work on, and next, and next, and then finish. Alright, so we have saved our file into downloads, and the next step which we'll do is we'll copy this file which we have just exported. We just combined all of this code after compiling into a .jar file. .jar is a bundle of your code, which basically you can think of it as a zip file of your compiled code. Okay, now word count.jar is your bundle of code, a bundle of compiled code, binary byte code basically, and then we are copying it to the server. we're copying it to the server. Student at Hadoop 1 dot no big data, and I'm putting it in a folder called asgiri. So after colon, I've put asgiri slash. So Seema's question is, do we have to copy it onto all data nodes? Good question. The answer is no, we don't have to. Hadoop will do that for you. All right. Now, here we have got ls minus lh. The flag h is for make it human readable. Basically, size is become 18K. If you don't put h, get something of this one. All right. Now, so we copied this from my local laptop. So Eclipse is installed on my local laptop, my Mac. I copied it from my laptop to Cloud Lab, okay, local file system. We did not copy it to HDFS. If I wanted to copy it to HDFS, I could have used Hue instead. Okay, I could have used web-based interface. That is easier because it involves only one step. I could have used this file browser. Now we have copied it there. Now the file is lying in. Let's try to launch it. We say Hadoop and then we say jar. So jar is a command instead of fs. If you want to interact with Hadoop file system, we say fs. But if you want to execute our code, we use Hadoop jar and we say word count dot jar. Let's see what happens. It says specify the main class. Main class is in sg package. There is this sg node you see, and here also at the top I mention sg, and our entry point is step driver. Okay. Now now it has run our program, and our program is saying the usage is our, basically we have reached here. Okay, it says that usage of the program is input directory and output directory. And what does our program does with input directory, output directory? It gets it as an arguments and adds it to the job using this syntax. Okay, so we are going to provide it the file path of our hdfs folder. Where is our hdfs folder? My hdfs folder which I want to provide it is here under asgiri, and under word count, and then under input folder. So this is our input folder. Okay, so quick way to copy the file name is this way. Okay, so you can either give it absolute path or you could give a relative path. I want to give it a, so we say it 24 Jan and say Java. All right, so now let it run and let's see what happens. So did we edit our code anywhere? All right, we did not change anything here. We have made it lowercase, replaced it with everything. Good. So let's just test. One more thing you should note is, so we were talking about error messages, right? Our program is in outputting this onto system error and this onto also system error. So let's see where does that go. Okay, so the mapper is running. Let's click on the mapper. Mapper has got one task, and the task has succeeded. The attempt has succeeded. If you go into the logs of the task, you will see that std error has got so many input files. And what does it have? Let it it's actually running something. So okay, so it has finished here. So it does something to count bytes and it is done. Also, these all numbers you should make a note of. Okay, you should make a note of, at least have a look at them when you are optimizing your map reduce. Okay, those numbers will be very, very useful to you. Perfect. Now the next thing I want to do is here. So this is the message I wanted to write here. It says this is a mapper. And where is it? Where did it come from? From here. All right. So whatever I'm going to put here, this actually you can see it on the task tracker URL which Hadoop gives you. You can dig down. Similarly, if you want to see what happened in reduce, you can refresh it once because the process is finished. Okay. So now task, let's have a look at the task. And okay, so this is a log. This is coming from our reducer, right? So this way you can debug what's going on in your reducer or mapper using these classes. Okay. So the answer is um, you will have to print to the std error, not std out. Okay, so in your code you should put it onto std error, because in case of, I'm answering Abhinav's question, can we do the same thing in streaming job also? Answer is yes. Make sure to differentiate between std out and std error. On every os you have got these two streams where you put the data onto. Okay, so either you put into std error or std out, because streaming job communicates to MapReduce by the way of std out as the output stream. So if you are printing log messages to std out, you will mess up with the normal key value. Hadoop will think that you are trying to print out the key values while you are trying to print out the log statements. So you make sure in your script that you are writing to the um, std error. All right. And other thing you could do with the I mean, you can actually write to any file you wish to in your mapper. Okay. All right. So that's all. The output is actually truncated here. Okay, showing 4096 bytes of total one, and there we go. Perfect. Now for here we have printed for each key. We could print it only for one key or when the reducer was created. All right, so we are able to successfully run the map reduce, and let's have a look at the output. Where did we keep our output? Under word count, under output 24J, and we have two maps and reduce, and you can see this. All right, now so we'll here save, right? All right, so we were able to successfully run all of this. And sometimes lots of people ask me this question, that hey, how do we talk to database, how do we talk to something like a file system, something like a central cache, how do we communicate with that when we are writing, we are talking in terms of key values here and there. Then how do we talk to the traditional systems? The answer is very simple. Whatever you are writing is a standard Java code. Whatever you're writing here is a standard Java code. So, which means any Java library will work fine. Or even in a streaming job, you are actually executing your code. In case you want to interact with any service, you're free to do that. Right? You're free to do that. So the only thing is, in case your Java program is connecting to some MySQL or something, in case your mapper is connecting to some some SQL server or somewhere, you need to include those libraries into your Hadoop launcher. Okay, and how do we do that? You basically using before you launch your Hadoop jar, you basically say Hadoop jar, your jar, the way we just did it, and then the driver name. The argument you specify is in the form. You say minus lib jar and a comma separated list of all the jars which you want to bundle together, right? Because Hadoop need to copy these jars onto all the data nodes so that they say you are using mail API.jar, which is basically email API, which need to be copied to all the nodes. If you have to do that, you will have to specify that on the command line argument. All right, great. So if you want to use external jars, third-party jars, or your organization has some libraries, you can use that, and you're free to do whatever you want to do in the MapReduce. Okay. Just that be cautious, as we noted that these things are called for each key, and this is going to be mapper is going to be called for each key value, each line. So in case you're hitting some server, you're going to hit it a million times using multiple computers. It will be more like a distributed denial of service attack. Okay, so remember that part, because all the trackers are going to connect to your service and trying to get the data. Your server might go down from where you're reading. All right, now good, good. So you just realized that it is such a pain to go through these steps. Go to file, export, then go to a wizard to export the jar, then copy this file onto the server, and then trying to run on the server, right? Program has access to the system environment variable through the context, through the context. Okay, so let me show you. That's a very good question, Amit. So through the context, you generally have access to a lot of things. You can see, um, okay, okay. So via context, you can actually access a lot of, get user, get working directory, get status, get task attempt ID. All of this information is available to your mapper via context class. How many attempts have succeeded, how many failed, and other than that, let me get configuration, for example. Okay, so you can access the configuration from here, whatever configuration parameters you have provided in the argument, and probably the environment variable is anyway available to you via system command line. Okay, this is common to the whole JVM, and you can access the env. Okay, your Java code can access the environment using this. These parameters will be different for different nodes. You are right. Do Hadoop jobs run in background by default? Suppose we are disconnected from the terminal while the job is executing. Will the job get killed? Very good. So Abhinav's question is, do our jobs run in no hub mode? No hub mode is something, even if your terminal get disconnected, will it keep running? The quick answer is yes. By default, all the jobs you run, they will not be there will not be any problem in case you disconnect. Okay, and even if you do control C, I mean, uh, put ampersand onto Hadoop jar ampersand, it will start running in the background, and you can continue to work on other things. Okay, so yeah, there will be no problem at all in case the terminal get disconnected. But I need to test it out. All right, now this is done. Okay, good, good, excellent questions. All right, so here we are. Now, you notice that it is quite a big pain to go through this whole exercise of uploading it to the server and then trying to execute. The whole process might take a minute or two, but you build this mental block that every time you might want to make a change, then every time you want to make a change, then you have to go through this whole process. Now, you will start doing is I'll make multiple changes together. I'll make multiple changes together and then I'll do go through these steps. And when you make multiple changes together, you can't really solve a problem. Okay, you can't really solve a problem. You have to make one change at a time and then test it. And that's a thumb rule most of the best developers follow. So if there is a problem, you generally solve it one step at a time. So to do that, you need to have a better mechanism, and for that, MR unit, MapReduce unit test casing comes into play. It helps you quickly test inside the Eclipse itself. Okay, so here is your test case. This is how your standard test case looks like. We are saying public class, and then we say stub test. This is before and after. Before we are launching it, so we create the glue code. Glue as in we are sticking things together, and yeah. So here we have, you see the mapper. Okay, you have, you basically first create something called a driver. It's actually quite a useless code. You'll be able to figure out if you're from Java background. Let's have a look at the test case. All right, so all we did was first we created a dummy map driver, reduce driver. We defined these variables. Okay, and after that the important part is here we say MapReduce driver, which is basically a class from MR unit. Okay, which is basically a class from MR unit, and we tell this MR unit MapReduce driver, this is the dummy driver provided by the unit test cases, that hey, can you run my mapper and reducer locally? Similarly, there is a dummy class for running the mapper alone, reducer alone. As we discussed last time, always test your mapper and reducer independently. Okay, and then you glue them together, and to test that, there are map reduce driver, which basically there is a class mapper driver, reducer driver, and mapper reducer. These are the three guys who will execute your class. Okay, so so you create these three instances which will be executing your code. Now this is how I have done it. Also, to the MapReduce driver, I have told that, hey, this is my input. Instead of giving the input in the form of file, I am giving in the form of key value pairs to the driver. Okay. So this is what I'm providing. I'm telling MapReduce driver that my input is byte count 1, and this is the text. Byte count 2, this is the text, and so on. Okay. So MapReduce driver, instead of using stub driver, I'm binding my code here locally, my mapper reducer, so that I can test mapper reducer together. Of course, I'm not testing stub driver here. We are not testing stub driver. We are testing stub mapper and stub reducer. And once we are done with that, we'll tell MapReduce driver to run it for us, and whatever output you get out of this, we are going to iterate over it. Okay. And right now we are just printing it. We are not doing anything. We're just printing it. Ideally, we should have been doing assert. Okay. We should have been doing assert, saying assert output dot output dot size is say 10. Assert equals, we say assert equals. So all right, this is what we basically test, that hey, this is how, these are the tests which basically tell you that is our MapReduce working fine or not. We basically are trying to run our MapReduce code locally, and the way we are attaching MapReducer together is using the driver provided by MapReduce framework, MapReduce testing framework, unit testing, MR unit framework. Okay, so you can see in the package we are basically relying on MR unit dot MapReduce, map driver, MapReduce driver, and reduce driver. Okay, so here we are. Let's run it and see whether how many errors does it give. Okay, so when we say run as, we say run at JUnit test. As you can see here, it says that expected 15 but was 10. Okay, so basically we should do this way. So there are 15 words in the input, and let's have a look. Okay, as you saw that this failed actually, our assert, and this is how you test your program. Okay, so there was a mistake in our test case itself. We fixed it. Now let's run it again. We click on this button and everything is run again. So here it says it succeeded this time, and important aspect is that it did output to the system. Okay, so it quickly did a nice thing for you. It quickly did a word count for you. All right, so it basically is also printing to the system out, and here we have. Make sense to you? Okay, now we can keep on fixing our code. Can keep on working with this code, and at the end of it we'll have everything running. You can you can set a combiner. Okay, you can set a combiner. You can set, I'm just trying to figure out how do you set a partitioner. Okay, I think you don't set a partitioner. Don't worry, I'll explain to it in detail with the example. All right. So great. So we were able to use MR unit to test our mapper reducer together. You can actually implement your own mapper, your test code for mappers. Here you could say, you could create. Basically, these are nothing but when you are talking about any JUnit code, every JUnit code has got something called, it starts with saying setup. Okay, we in the setup we do things which need to be done only once, and then only once before the test. And here we write every function which we want to test, either we annotate it or we start the function name with the test. But to keep the compatibility in place, we do both. All right. So we put a test as the first, start our function name as test and do whatever we want to test here. Okay. It's absolutely up to us. As many functions we want to write, if you want to say, we want to say test mapper whatever, or we want to say text xyz, that's absolutely fine. Okay, all you need to do is run it again. Okay, so this is failing now. Okay, and if you want to test it correctly, we say assert true 10 equals 10. Right? So now you can see that everything is working fine. All right. All right, there we go. Now, so we have been able to, is my test cases, did you understand the benefit of running MR unit? This is MR unit basically. Great. Yeah. So basically, instead of moving back and forth between your Hadoop installation and trying to overload your cluster, you will use this, right? All right. So let's take a break of 10 minutes and back by 10:12. Hi, so should we start? I'm back. Hi, can you hear me? So should we start now? Just that I see attendee as 10 instead of 11. Okay. All right, then let me start. Yes, so you at minimum you require three classes to write MapReduce. Right, that is correct. And also note that you can actually use this, you can actually shift this stub driver code into any of mapper and reducer, then also it will be fine. But it makes sense to keep three classes, okay, rather than making a little mess. All right, so perfect. So here my discussion point is the relationship between input splits and HDFS blocks, right? So if you remember that when we were talking about HDFS, we said that HDFS slices when we are storing the driver, the client Hadoop HDFS driver splits the file into blocks and then the pushes those blocks to each data node, to the various data nodes, right? There we talked about that it doesn't think about anything other than the block size. It ruthlessly cut the block at 128 MB and then put it onto one data node and another data node and so on. It doesn't bother it whether it's cutting the byte into half. If you have got, say, a int long, a big number which is occupying multiple bytes, so half of the number might be on one block and half of the number could be on another block, right? So now, but when we were dealing with MapReduce, we noticed that we got the input in proper format. So who does the magic in between? And how can we control the magic in between? Okay. Also, if you, to again explain the point, so there is some block boundary. Okay. Say there was a line 1, line 2, line 3. So imagine this imagine this fictitious file which has got three lines. First line is of 50 MB, second is of 50 MB, and third one is 50 MB. And or let me just try to make double it. Okay, this was done in order for 64 MB. Okay, so block 1 is going to contain, okay, actually it's correct only. So block 1 is going to contain line 1, line 2, and some part of line 3, while block 2 is going to contain the remaining part of line 3. But in MapReduce, we got the line as a full line. We did not get half of the line in one of the map function to our map function. We got the whole line. Now, who does the magic? So this magic is done by something called input splitters, right? So input splitters job is to read blocks and transmit it to the next input split or keep it in the current input split. Okay, so input splitter is something which does this job of going back and forth and making it possible to provide you the full input in whatever format you want. Okay, now what is input split? Hadoop divides input into pieces called input splits. So when you launch your Hadoop job, input splitters start their work. Okay, they will start reading the blocks in case some part of the file they are not able to, some of the bytes are belonging to the next input split, they transmit it to the next one. So that's the job of input splitter. Okay, one mapper instance per input split. Okay, this is something which will look awkward in the beginning. So as I was telling you that you have a class called stub mapper, right? This class have to be instantiated onto each node, meaning this class has to be loaded onto each node, right? And it will be loaded for each input split. So out of the whole file, some lines will be on one node, some lines will be on another, and so on. For the whole set of line, we will be creating one input split, then another set of line will be creating another input split. The only difference between block and input split is input split will have full lines instead of half lines. Okay, instead of having basically the boundary things will be taken care by input split. Now each input split contains many records, and a record equivalent to our example is a record is a single line. An input split is basically bunch of lines. Okay, so an input split consists of many records, and records is what is fed to your map function. If you, so basically you can customize input split. The logic of input split can be customized. In case you try to create very small input split out of the HDFS block, you are going to have too many too many movements, right? See, as we talked about on each mapper, for each mapper, one input split would be there. So, which means you'll have multiple mappers across your cluster. Okay, you will have multiple mappers across your cluster, and then there'll be too much of movement of the data from here and there, right? So the general tendency to keep is that our whole block should create one split in full instead of hundreds of input splits out of one block, because each in a split will be running on different machines, and therefore the data will have to be transferred, right? Therefore you tend to keep your input split size closer to the HDFS block size. Okay, you cannot keep it exactly 128 MB. Why? Because 128 MB may not be logically correct. So on top of HDFS block, each of the block, we tend to create our input split. Okay, the job. Okay, so on top of each HDFS block, we tend to create input split, which is a logical representation of data. Okay, if your file is in binary format, let's say if your file is binary format, there will be some class which will create input split, which is logically correct, which is a logically valid uh, view of your binary data. It will not be basically a input split is the logical view of a section of your input. Okay, it's not simply bytes, right? It's not simply bytes. It's a logical representation of your data. The way we said line is a logical representation, or a sentence is a logical representation. But uh, but if you talk about number of bytes, that's actually something which is stored on the disk. Okay. Make sense to you? So these two lines are not something to do with, okay? Just a second, somebody is trying to call. I don't know who is this. Okay, so Mega, is this clear? Should I explain again? So basically, we are trying input split is a logical representation of the data on top of HDFS block. While HDFS blocks are created when you're storing data, the input split is created when a map reduce is executed, because every map reduce could have a different logic in place. One map reduce might be trying to do the work line by line, but other map reduce might be trying to operate on on this file in the form of binary, or another map reduce might want the whole file in one go, and so on, right? So therefore, that is the sense of input split. Now, how do we create it? So while launching our class, you must have seen, while launching our class here, we said it's not mentioned here, but in this one here we said this is our input format class. Okay, so we provide something called input format, and input format is the guy who is responsible for figuring out how to who behaves like input splitter. Okay, so we'll go into the details of that one after this one. So record equals to one line, input split equals to n line, yes, and block can be n minus half line. Perfect. Is that right? Yes, Seema, you are very, very correct. Okay. So is this clear to all of us what an input split is? You have questions? Okay. Nakul, are you there? Good. Good. So, Shashant, is this okay with you? Because I found lots of people a little bit confused about input split. So now A record is basically a further division of input split. For each mapper, we create the whole input split in one shot. Then the map function, which is going to get executed again and again, is called a record. Okay, a record in our word count is the line. And if you are talking about a database, maybe a row is actually a record, and a bunch of rows is equivalent of input split, right? So map function is applied onto each record. A record is a logical entity. An analogy is RDMS's row, and input format is the guy who is responsible to create records as well as input splits. Okay? Yes. So in the analogy to input splitter could be a database view. Okay? But the database view is generally the whole rows, bunch of rows, or there's only one view over a database. Here, on top of each table, some of the rows go to one input split, some of the rows go to an next one, and some of the rows go to another one. And on top of each input split is being always each input split is always processed on a single node. And this whole input split will be fair. I mean, for each input split, the single instance of mapper is going to get created. And on top of it, on top of each record, we execute the map function. Do we need to predefine size of input split in terms of lines? So that is the role of our input format. Input format is the one, it is up to the input format what kind of option it is going to provide to you. Say, for example, we will be talking about something called n lines input split, in which it will be providing you n number of lines as a record. Okay, and generally it wouldn't make much sense if you have to say input split, you have to be really optimum. Say the word count problem, if we want to keep it optimum, it wouldn't make sense to specify number of lines. Why? Because we want to deal with we want to deal with uh, blocks, right? At the end of day, we want to deal with blocks. So our input split, the size of input splits should be equivalent of our input block. And lines, one line might become say 100 GB, or I mean one line might be say 100 MB, another line might be a smaller, and so on, right? So maybe in one of the input split there is only single line to be processed, while in the other input split there could be 100 lines to be processed, based on how big is the line, right? So it wouldn't make much sense to keep the number of lines as fixed. Otherwise, there'll be too much of data movement. So idea is, when you're creating input split, you also keep in mind that our data movement should be minimum, because another input split is going to be processed by next node, the other node, right? So the data need to be transferred from one node to another. This half of the line which you told, this half of the line has to be moved to the next node, which means that this half of the line is going uh, is going to take the network traffic, and there will be a delay. Perfect. Great. Great set of questions. Split only makes sense in file input. Can I override input split for some other input like getting record? So yeah, because for the any map reduce problem, the only thing which is divisible is data which is lying on HDFS. Okay, that's what is our deciding factor when we are talking about mappers, right? But but having said that, having said that, okay, it's a brilliant question, Amit. So question is, say you are writing a job such as you are writing a tool such as Scoop. What does Scoop do? Scoop basically moves data from the databases to our HDFS, right? Now, and we want to create map jobs for that, right? So, and we want to create the map jobs for that kind of thing. So, yes, you can actually create input split for reading from databases and also devising a technique to split number of rows to be read on one node and number of rows to be read from another node. So if you have three nodes and all these three nodes have to import the data from a table from MySQL, they can divide the input into that format. Scoop exactly does the same thing what you're mentioning, Amit. What if line size is greater than the block size? That's a good question, Swati. So in those cases, the input split, one of the input split is going to be bigger than the block size. Okay. All right. I guess input splitting should happen for structured as well as unstructured data as everything is stored in HDFS. Yes. All right. Now, all right. So this was what is called records. Now, in a very, very simple way, the entry point into the whole game is input format. So whenever you want to create your own input splitter, you extend this class called input format. So input split is created on a block which is already a chunk of data. So input split is created on block which is already a chunk of data, yes, on every node. Yes, that's right. And the sum of the chunk of the data moves between one node to another in order to make a logical sensible input split. Yes, node contains blocks contain input split, and input split is further divided into records, multiple records. Perfect. And this input split is fed to our mapper, and gets map function get executed on each record one at a time. Great. So now say you want to create your own input split format. What will you do? So first thing you will do is, actually before we talk about, I think this slide I'll just move it a little to the back side. All right, let me first explain to you few things which are available rather than jumping into things. Okay, so what are the various available input splits? Okay, the first one is text input format. That's what is the default, and that's what we used when we did word count. In case of text input format, the input size is input split is bunch of lines, and record is a line. right? And whenever you are setting a input split, you basically set let's available input format. Let's call it available input formats. Okay. So we say that job dot set input format class, and here we go. And by default, it is text. By default, it is text input format dot class. Even if you don't mention it, it's there. Okay. Now, so by default, it is one. And in case you want to change the new line slash n with something else, the one which is record delimiter. What is it that separates one record from another? By default, it is slash n. If you want to change it to something else, you can do that. Okay. So one quick strategy of solving our problem of tuples will be that I will set this delimiter like this. And now I'll get paragraph whole paragraph in one of the mappers, then I'll read the whole paragraph and split it by dots, and then I have sentences inside each map, multiple sentences, and then process it. This process is good as long as our paragraph can fit into the RAM at a time. You cannot have, that's the downside of in text input format, you can have only the single delimiter, not an array of delimiters. Okay. And I need to check, I think it is a single character, so my plan of having it like this may not work. That I need to check. I think it's a single character one. This is what I checked last time. Okay. All right. So my plan may not work. So the default one is text input format. This is one which we have been using without specifying anything. Then there is something called n line input format provided by the same guys, where we can we can say that we want to have n lines of input as one split. As I think Seema or somebody was saying that can we specify number of lines? So this will be your choice. I think Megha was okay. So I forgot the name. So number of lines if you want to have on one node, then probably this is your choice, n line format. So each input split will have fixed number of lines in the input. Okay. So number of lines in case you want to process, and basically if your process is very intensive, okay, if your process is very intensive and you want to devise a mechanism so that you can process fixed number of lines and distribute the load equally, probably specifying number of lines of input will be a good idea. Okay. So here, how do you specify these things? Using a configuration parameters. Okay, job dot set conf dot set this. So set name value pair. You can set the set this key and value here to pass the information to the input splitter. Okay. So this is one another input format provided by, as you can see here, we can say here job.set input format, and this is there. Okay, so it is available. Okay, this is actually my class. This is my class actually. Let me remove it. Let me just name it. All right. So here we have good. So it is called n line input format. Perfect. So it will give you n lines. Sometimes the other case, Abhinav, would be that your data is structured in a way that only n number of lines make sense. Okay. Sometimes you have the record formats, which make sense. So those are the other use case. Now there is something called fixed line input format. Okay, this is something fixed format. Have you guys heard about fixed format? Fixed format is something where each line has got each line has got the input size of variables defined by number of bytes. Okay, even if the data is smaller, still it will take the same number of bytes. So first 10 characters reserved for first column, next 10 characters reserved for second column, next 30 characters reserved for third column, and so on. So there are many such file format which we call fixed file format. Okay. So if you want to process that kind of file, you might use this input split format. Yes, it is going to apply on the whole cluster. Okay. Wherever the mapper is going to run, this logic will get transferred over there. Okay. Now, okay. So the input format could be absolutely in the binary format. It could be byte by byte, not necessarily the whole text. It has to be a text file. It can be bytes also. Okay, because fixed format is found in lot. I mean, in lot of cases, format is found in the binary data, and you can specify the record length by calling this function as well. Okay, so it makes it easy to call that function if you want to call it. Okay, so we could say, okay, like this. All right. For time being, I'm commenting it out. Good. Now the next one is key value text input format. Can we have different input split format for different nodes on the cluster? No. That kind of logic you have to build in your input format, input split in your input splitter itself, where we could take a call based on which byte are you operating. I was answering to Mega. And then there is an interesting one called key value text input format. This is good for handling plain text file where our input is in the form of key and value. Okay. And here it uses slash n or slash r as the end of line. Each line is divided by key and value. In case, okay, and the separator you need to define by using this parameter. Okay, whether the separator between key and value is tab or it has to be a single character. Okay, yeah, and so on. So this way it is going to be this is quite useful when you're dealing with uh, formats which have key and value, and so on. If this particular byte, which is your separator, is not available in the line, the whole line is going to be considered as the key, which is being given to your map. Now, there's something called sequence file input format. This is probably the little more interesting one. The default separator, I'm not sure. I think it's tab. Okay. Let me figure this out. Key value text input format. What is default separator? I think it's tab most likely. Or maybe I think equal only. Okay, let me find it out. Now, there is something called sequence file input format, and this is good. When you have to read a binary file, when you have a bunch of hundreds of binary files, imagine this: you have hundreds of binary files. They need, and they are very small files, 10 bytes, 1 MB, 2 MB, 3 MB, and so on. Now, it doesn't make any sense to process these files independently on one node. You would might like to process multiple files on a single node. So generally you would wish that maybe I can, uh, form some sort of way that I can process multiple files on one node and whatnot, right? So in most of these cases, when you have to handle binary data, you create something called a sequence file. There are many tools to convert your files into sequence file. Sequence file is of this format. Sequence file is of the format. It's for handling the binary data. It has got binary key and binary value, and there is a detail header. Okay, there is a header in sequence file, and the header contains lot of information. So So there are multiple kinds of sequence files itself. Okay. Say for example, the header is class name, value name, compression, block compression, and not whatnot. And so basically, whenever you're dealing with binary data, you would most likely want to deal in the form of sequence file input format. Okay. And specifically when you're dealing with files, a small number of many files, then you would like to create a zip file out of all your files and then convert it into sequence file. Okay. And there are few converters which are available uh, to do that. For example, there is a gzip converter. Okay. So the way we have been doing is using the create a gzip file, and I mean using a tool called gzip, and then using these kind of tools we convert it into sequence readable. And once we are done with that, we feed it to our MapReduce via this input format. Okay, so have a look at both these things. And there is something called LJADO format. So in lots of cases, what happens is the input data which you want to give to Hadoop should be compressed, right? Or whatever we were keeping on HDFS to avoid taking too much of space, we generally compress it. Okay, we generally compress it. So there is a blockwise compression tool called LJADO. So unlike your normal zip file in which the whole file has to be a single file, this one gives you an option to compress each block so that each block can be decompressed and used. So in lot of ways, you use Aljado as the format, Aljado is a compression standard for keeping your data in the HDFS. And internally, for most of the input splits, almost all the input splits, you can specify that, hey, my input is in Aljado format before feeding it to input splitter, before applying our input splitter, apply, decompress our block into Aljado and then use it. Okay, that kind of features are available by Hadoop. Okay, these are the libraries. You can have a look at it if you are curious, further curious. Okay. Okay, so have a look at this. Look at both these splittable gzip in case you want to handle big files. The other important part is in case you want to read the file from another, from HDFS or another system directly, you can do it easily by doing file system and then URI dot create URI and then file system dot get. Okay, this is absolutely okay. All right. So here, in case of stub mapper, you could say public stub mapper. Okay, you could say this. Okay. So if your URL is equals to HDFS something, you could basically use that. All right. So sometimes what you want is you want the whole mapper to read the file and then operate upon it. Okay, in those cases, to your mapper you will basically pass a list of files. Okay, to your map reduce chunk, you will do is create a list of files, and the list is the only thing which is being fed to your mapper, one line at a time. And then each mapper is getting one file at a time, and then inside this mapper here you might be reading it. Okay, so this way you can actually access any file system from inside of map. So sometimes a lot of people ask that, hey, all I want to do is I want to in my mapper I want to do is um, process my files. Okay, full file at a time. Okay, so my answer is that create the list of file, give it as the input to your uh, mapper, the list of files as the input to the mapper, and inside the map function read one file at a time. You will get one file at a time and then start working on that. Okay, you can start reading using this. All right, so that's also one way in case you want the full file at one node. Make sense to you? Should I move on? All right, so now say none of these things which we just discussed are fitting to your need. What you want is you want your own custom input reader. You have your custom format, you want your custom reader, or you want to have a custom way of creating input split. Now what would you do? Okay, first of all you will create a class called input format by extending input format, and then you will implement a method called get splits, and then you will override a method called create reader, and where you will create your own record reader. I'll show you this. You'll create your own record reader. Let's have a look at the M lines here. Okay, so this is my format, my N lines input format. I'm extending a class called text input format. This guy does not do anything with it, doesn't override the get splits behavior, it leaves it as such. But if you wish, you can do that. And basically each input split is essentially the length of each of the input split and the locations of the data, the locations of the data. Now here we are not overriding that one. So all we did was we gave a reference back saying this is my record reader. And what does my record reader contain? This is the record reader content. This is little complex. It extends something called record reader. It has a data type of long writable and text. Okay, and here, so we are saying that the key which our record reader is going to return is long writable, and the value is text. The record type is text, and it is this. All right. Here, where is our get record here? Next value. Next value is going to be, yeah, value get current value is going to return text here. Okay, so you override all these methods. First, what to do when close is called, what to do when current key is called. All of these methods you are going to implement. If current value, the user wants current value, this is what it is. And you have to override all of this. And get progress also you have to implement, because mapper, when it processes your data, the Hadoop has to display the progress to the user. Okay, and anybody who wants to use MapReduce will be calling this function get progress on top of your record reader. So you'll have to do that. Initialize is something interesting. This is the logic which is going on here. Here it is skipping the values. You go through this again and again. It tells that till from what point to what point you need to read the data. Okay. And then whenever a next key is called, then again it starts reading the data, and it breaks at a point whenever the max length is reached. Okay, so go through this custom reader. The code is available in the learning management system. So this is a good starting point to look at what all you can customize in case you plan to build your own input reader. You could use this. And most likely, in case you have a custom demand, I bet most likely you will be able to find it online here and there. There will be some GitHub project which would be doing exactly same thing what you are trying to do. All right. So for example, I was talking to one guy from NASA. Those guys were trying to decipher the files in the form of imagery. Each file was basically a GPS, a satellite imagery data. And interestingly, there was a project which we were first trying to implement it ourselves. Then we realized that let's give it a shot to search it. And there was a GitHub project who was doing exactly the same thing. Okay, given given a data format, they were actually trying to provide you an input format which you can use over large set of imagery data, right? So before you start trying to implement your own input split, try finding it. But in case it's for your learning, then you should definitely give it a shot from end to end. Okay, yeah. So when you try to implement it, then you will have more clarity. on it. Okay, Sahu, are you with me? I'm not seeing your update. Great, great. Now, so this was how you would modify the input split in order to fit your requirement. Okay, so have a look at it. Have a look at it. At least go through it once. At least you will get more or less the clarity that when to go for your own input split and when to use the existing one, and what is it that it can provide. Okay, all right. So great. So let me just go through the diagram which we discussed earlier. Let me go through it again. So this diagram is clear to everyone. Okay, Abhinav's question is, can we do the input split kind of customization in streaming jobs? The only thing you could do there is specify your input splitter, input format. Okay, all right. So that's the only thing which is there. So even if you don't brush your Java concept, I would suggest a better way of brushing your Java concept is just pick the existing code. The one which I have provided is actually a pretty good starting point. Okay. So that you don't have to get into language semantics too much and just focus on the logic itself. All right. So Abhinav, yeah. So in case of a streaming job, at most you can specify is you can change the input splitter, or you can, meaning you can change the input format. That's all. All right. Now, so this slide is clear to everybody, right? So here what's happening? There was HDFS. On top of HDFS, split 0 was created, split 1 was created, split 2 was created. Before this, there was a little bit movement of data from one block to another, and so on, right? Now, when we had this nicely formatted input split, the mappers instance is created and each record is fed to our map function. And for each record, okay, for each record, the data is gathered here in a circular buffer. We call it circular buffer, okay, and which keeps on pushing it to the buffer. On the other end, there is a sorting happening locally, as well as and once sorting finishes, and this job finishes, and once similarly all other jobs are going on, once everybody finishes, the data gets copied to a central place where the merge happens, and after merging, there is a single file forms, and then I mean, after the data is merged, then it is fed to your reducer, and for each key, okay, for each key, all the values are fed to the reducer and then goes to the part data file system after running your reducer code. All right. Now this one is little interesting. This one is little interesting. So suppose you have two reducers. So while sorting itself, before sorting itself, the data starts separating into two buckets based on some form of logic. Okay, the logic could be do a hash code. If the hash code is even, put it in one bucket. Hash code is odd, put it in another. Okay, if you have three reducer, try to divide it by three, and whatever is the remainder, put it in that bucket. All right, and so I mean, try to divide the hash code and by number of reducers, and whatever is the remainder, put it in that bucket. Good. So that is one way, and these buckets get carried over to each reducer, And if you have n number of mappers and m number of reducers, so total network transfer is n into m times. Okay, therefore it is going to take, in case you created so many reducers and so many mappers, it is going to be a little tough on your network. Okay, now a common question is that how many reducers should we have? By default there is one reducer. In case there are too many reducers, effort of shuffling is really high. Okay, as we saw, if you have n number of mappers and m number of reducers, n into m is the total network cost. All right. Also on each node here, the division of data will happen and the different buckets will be created. So there might be a little bit of overhead on each node itself. Okay. So that is one thing. Now, all right. Now, so sometimes it is important for you that you want to create your partitioner so that what data goes to which partition is defined by you. Okay, what data is going to which reducer is something which is defined by a partitioner. And ideally, if you know about your data better than Hadoop, probably you should take that call. Okay, if you know that in case we divide our data using this particular key, it will be better. As we talked about earlier, that we will be having word count in reducers, in multiple reducers, and in case we want to combine all of the data of reducer, it is going to take uh, a lot of efforts to combine the data and again sort it, right? As you saw here, as we saw here, if you let's have this. So we have two files. One is this second part. This is first part. Okay, this is the first part. And now if I go to the second part, okay, that too has the same sequence. If we want to merge these two parts, part 1 and part 2, it is going to be too much of an effort. Okay, but part 0 and part 1, right? We'll have to again sort the data after merging. What if we could divide this data such that part 0 and part 1 has nothing in common and they are one after another, right? So it could have been like wonderful. We could have just combined, concatenated them together, and that's all, right? So let's try to do that. So I have actually made some mistakes here. What is the mistake? Yeah. Now let's have a look at what's going on here. Let me just clean it up because we made some changes and because of which. All right. So if you want to create your own partitioner, you could do something of this sort. Okay. You could create your partitioner class by extending partitioner and then implement a method called getPartition, which is supposed to return a number. This number should be between 0 and less than number of reduced tasks you have. And this method is given few things. One is key, other is value, because it is going to be executed just after your map spits out data. Before the sorting starts, partition is going to get called. Now And you are also provided number of reduced tasks available in your configured for your job. Okay, so what will you do is you will say you'll return a number between 0 and number of tasks. Okay, and you can take any call whatever you want to take here. Sorry, this is going to be a little different. Okay, and instead of having it implicit, let me say it explicitly. Right, this is what we could do. So this is our partitioner, and let's have a look at our partitioner here. Okay, here what I did was I did a little bit of magic, and I said that in case our data is greater than less than k, then return 0, otherwise return 1. Okay, this is what I did. If you have two partitioner, this logic is great, which means partition 1, the output of the this diagram, if you see the first block, this first split, first, sorry, not block, not split, first portion of the output is going to be less than k, and going to start from something which is before k. It could be j, it could be e, it could be a, it could be g, or it could be 0. And the second portion will be something which will be k or more. Okay, and then that means these parts are going to be different. So let's try that out. All right, let's try that out. We go to our driver and we say that this is our partitioner. Okay, this is our partitioner. Now let me create the export. Okay, are you clear about the use case what I'm trying to do? We are basically trying to say that all keys that start that are before k should go to the first reducer. All the keys after k should go to the second reducer. And let me copy the data. So I'm copying it again. Good. Now let's run it. So we said output 24 Jan dash J1. Good. So Julie's question is how concerned should we be when we are choosing the logic as to the size of the two parts? You should be very concerned. Why? Because mostly the reason why we create our custom partitioner is in order to balance the size. Okay, in order to balance the size, so that all reducers are equally busy. One reducer should not be extremely busy and other should not be very free. Therefore, you should try your best to keep it very, very, very equal in number of load, in terms of load. Just to confirm once, one set of keys will only go to exactly. So one set of keys will only go to one reducer. It cannot go to multiple reducers. Yes. Therefore, by using this logic, our two files, part 0 and part 1, are going to be concatenatable. We should be able to concatenate them, right? Now let's have a look at what's going on. Now here, if you go into this here, now you see all the zero starting with numeric and up to j is here in the part 0, and everything, sorry, sorry, and yeah, and everything after j including k is here, right? And now you can concatenate them together and be happy. You can easily concatenate them and your data will stay sorted. Make sense? So that was the magic done by our partitioner. And right, so so that is the role of. So if you want to sort them by values again while concatenating, it would not be wise to basically do it locally. If you want to do it locally, it will be a big problem. You might have to go for another set of MapReduce phase. Okay, concatenating. When I'm saying concatenating, we can simply say get merge. Okay, we simply say get merge here, and we merge the two files. And I mean say cat1 cat file1 comma cat space file2, which means these two files will be just printed one after another. All right, so that was our demo, and a valid reason why we should be using partitioner. Okay, now the combiner is something which you guys already figured out, that that you required something of a combiner. You remember our problem of counting characters, right? Where counting characters, where we were just going through one character at a time and then trying to count number of characters, right? So in that case, it will be great if you could combine all the output in on one node in a single shot. Okay, let me show you in my project here. I say it char counter. Okay, so here this mapper basically goes through the line and writes the characters this way. Okay, here it basically says for each character is my key and the numeric is 1. Okay, this way it creates a huge input on each mapper. Now, if you do not have a combiner, instead of sending 26 variables, you will be sending all of this list again and again repeated, right? You'll be sending this whole list again and again repeated. So instead of doing that, you could say that, hey, let's have a combiner which combines these values together and then send it. Although the important part, you should note that combiner, basically combiner is like your exact reduce. Okay, here it's not guaranteed that all values for the key will be available to you. Okay, therefore your combiner has a little bit of different semantics. We'll talk about those now. Okay, so since the combiner is executed on less value, not all values at a time, instead it is applied on some values at a time and then some other values at another time, and then whatever is the result, it is applied again to combine the result together to form the values, which means that not all functions can be a valid combiners. They have the the combiner should be such that the combiner logic should be such that if you apply again and again on the result of previous executions of combiners, you should get a valid result. Okay, something like a divide and conquer. Okay, so a combiner runs on the same node after map has finished, processes the output of map. Second, it helps to minimize the data transfer, but it does not replace the reducer. It is only done on a single node. The other property which is important is the signature is exactly like is basically the same as reducer. That might convince you that it is exactly like reducer, but there is this difference. So if your combiner's role is say max, okay, so it will be applied on some portion of max, some portion of the result once, then some portion of the result afterwards, and and later whatever is the result, it will be combined again and again and again. So it will be applied recursively on your values till you get the result. So combiners is like your the way you sort the data. If you want to sort the data, some portion first you sort. I mean, it's like divide and conquer, right? So reducer, in case of reducer, all the values are available in a single sort, which means you could do whatever you wish to do, right? But in case of combiner, not all values are available to you. Even on the local node, some values, for some values it is applied, and then another values and another values, and it is applied recursively. Okay, you can say that it's a kind of a filter, but let's take a case of of so what I'm trying to explain here is that not every function qualifies to become a combiner. For example, average is not a function which can be a valid combiner. Why? Let's take a case. So let's say you have got these values. What's the average of these values? Can somebody quickly tell? What's the average of these values? Average of this, how much? Somebody quickly. So let me see if I can do a quick Python here. Okay, I think instead of writing right now. So yeah, so average is how much? So divide by 4. It cannot be 14. 20 plus 10, 20 plus 10 plus 25, divide by 4. So it is 13.75, right? Now, let's say we do it in parts. Average of 0 and 20 is how much? 10. Average of 10 and 25 is 10 and 25 is 17.5, and now whatever result we got here is 10 comma 17.5. What is the average, right? So we were lucky that we got the result correct here. Okay, but now let's say that we have these values. Okay, average of 25 is 25. Now let's say 20 plus 10 divided by 3 is 10, plus 25 divided by 2 is 17.5, right? So if you apply average on some portion of data, we realized that if we keep on applying, average is giving us a wrong result, right? So functions like average are not a valid combiner function. Yes. So functions, they have a very good name. They are called, I think they are called reflexive and symmetric. I need to see the definition. So, but forget about the definition. I want to explain to you what kind of functions are a valid combiners. All right. So these are the valid combiners. This kind of functions are not, average is not a valid combiner, and sum is a valid combiner. Why? No matter how many values you sum it at once and then you sum it again and again, it will result the same thing. Now, Root mean square value. Okay, who knows the root mean square value? RMS is square root of a1 square plus a2 square plus a3 square. Okay, a1, a2, a3 up to an square, and all of it divided by n. N is the total number of values. Do you think it's a valid combiner? Anyone? Okay. Swati says no. Anybody agrees with him? With her? Okay. So Julie, you say yes to agreeing with her, or you are saying that it's a valid combiner? I'm sorry to ask confusing questions. So this is valid combiner, true or false? So if you have a function which basically returns the square root of root mean square value of all the values for a key, do you think if we keep on applying recursively, it will still give you the result correctly? This is a very important function, and uh, we will come back to these kind of functions again when we deal with Apache Spark. Okay, because there in Apache Spark the reducer is exactly like combiner. It operates on few values once and few values at other point of time, and that's when the problem starts. All right, so yes, this is not a valid combiner. The statement is false. Okay, and now let me ask you this question: had there been no slash n, was it a valid combiner? Anyone? Now, are you sure? It's a square root of sum of squares. So let's try that out. Let's say you have a1, a2, a3, three values. Okay, the result will be at the end of it. Result will be, okay, we'll have this. All right. Now let's take a case of a1 and a2 at once. Now the result is going to be for a1 and a2 this, right? And then when we combine it together, we are going to say, let's say this value is how much? X. Okay, so x into x plus a3 into a3 and then square root. Okay, now if you see this, okay, so after this what will happen is when you do a square of this, you will have these values, right? Now we'll have sqrt of these values plus A3 into A3, right? So you got the idea that what kind of functions are valid combiner functions. So Seema is saying that had there been no square root, then it will be valid, but I think it will be valid now also. Makes sense, right? Is everybody clear about what kind of functions are valid combiners? I can give you a few more example if you wish. So Sushant is saying this. Sushant, should I give you one more example? So let me give you an example. Say min. So do you think min is a valid combiner? Good. Max, sum. Yes. You need to be careful before before choosing a combiner. You should not be blindly choosing a combiner just like that. Okay. Well, you are writing a code. So let's say, let me ask you, if you have to, it is important that do do a computation of average. You have to do the computation of average. Then what is it that you will do? You are trying to compute the frequency of characters. What is it that you will do? The average frequency of some value. Okay. Total number of values if you're given, you have to compute average as a result of a reducer. Okay. Now what will you do if you have to do that? One is that you say, I don't use combiner. I don't want to use combiners because average is not a valid function. Can you convert your problem into such that we could use a combiner happily? Yes, you could use sum in combiner. Excellent. And but at the end of it, we want average, right? So we would need a count also. So basically, in case we are doing average, average is not a valid combiner, right? So if you want to do computation of average, we will do something like a sum and count. Okay, sum and count, and sum and count of values, and all it does is it provides you, it returns returns a sort of a value which is number colon number. Okay. Okay. Here, all the values it will be getting is sum and count. Okay. Here, as a result, it will say 1 comma 1 and 3 like this. Okay. And so on. Right. So you will basically try to figure out that can I can I use a combiner? Can I convert our combiner such that uh, can I convert my function which is combiner into something which can be applied again and again, still it makes sense, right? So in case of average, instead of only doing a computation of average or doing something of that sort, what will I do is I will do something called summation and count together. Now, summation and count, I will result as the output of my words. Okay. So if I have, I'm trying to compute average, I'll basically count, compute sum and sum and count together and then print it. Or there is one more better way, saying I'll compute the average and also mention that how many values my average function will return how many values it has been computed upon. Okay, and there are few more techniques, because when you try to do computation, there is a heavy chance of going into integer overflow. All right, so that's pretty much about combiner function. I think we can take up rest of it tomorrow. All right, or next weekend, but no, you have not missed out on anything. All right, so you can basically go through the rest of the slides also if you wish to complete the assignments. All right, and so the assignment for the whole session is code the all four five problems which we have given so far, including the tuples, and try to finish all the assignment given so far by next weekend, so that, because next weekend we are going to start with pig, and then there is going to be more assignment over there. Okay, and then next weekend pig and hive are going to get finished in next weekend, and then the work is going to increase. So it will be better if you just finish all of this week itself. Is there a place? Yeah, yeah, there is a place actually. If you go to my, if you, okay, let me, if you go to my courses on no big data, so go to my courses into no big data, and there you will see only one course called 24th January, and there you will see all the slides here. Okay, the presentations, the installation instructions, everything is there. Okay, is this what you're looking for? And here you will see the project. This sample project contains everything. This one contains everything. This one is simple word count. And then for further reading, you could actually look at this book called Definitive Guide. This is a pretty good book. And in case you are planning to go for the certification or something with Cloudera or Hadoop, this is one book you would love to follow along along with our sessions. Try to solve the problems which we have given, and most of these things will be quite simple to you. Okay, so in the session you will see all of these things here. Okay, you can see the presentation, and all of these presentations are available here. All right, good. So that's pretty much for today, and we'll see you on the next weekend. All right, so if you have any doubt, just drop me an email, and yeah. Great. Thank you, Susant. Thank you, Swati. Thank you, Julie. Okay. I'm happy that you found it good. I'm actually pretty happy with this particular class. We have got really good candidate in this class. Thank you, Nakul. Brilliant questions you guys ask. I'm pretty happy. All right. So we'll see you on next weekend. And till then, keep working. In case you have a problem, just drop an email on at Hadoop at no big data. We track that email ID separately so that we don't miss out on your questions. Okay. And yeah. All right, then have a good day. Bye bye.